It is a great delight that today I have an opportunity of meeting you once again. It is my prayer that God will continue to protect and preserve us in this crisis of the coronavirus pandemic. It is my prayer that Seto, as an institution, from the proprietor to the staff and all the student body, even the parents and the guardians of our students, it is my prayer that anybody that is connected to the school will be preserved and protected and will be secured in the blood. That among all the problems and the calamities that are going on for us, it will manage us. In Jesus' name, amen. In our previous section, we continued looking at questions under preparation of gases. And you were left with 3 more questions. I ask you to try your hands on them before we meet again. So today we're going to look at the remaining 3 questions that are left on the preparation of gases. And then when we are through with that, we will have another 1 more section to complete the chemistry practicals. That is to look at questions on titration. So today we're going to continue by looking at question 16. Question 16. Now question 16 reads, it says, the figure below is an illustration of the setup for laboratory preparation and collection of ammonia gas. So it means that the gas that is being prepared here is ammonia gas. So you have the setup given, and it says that study the figure carefully and answer the questions that follow. Question AI says you should name the parts labeled I to VI, and the I says you should give 1 function each of the parts labeled I, and IV. Okay. So question 16. Question AI. We are supposed to label the part from I to VI. So I, IV, V, and then VI. Okay, so from the diagram, the part labeled I is round bottomed flask. If you look at the previous questions we've solved, we've come across flat bottom flask. So for that one, the base is flat. So the flat bottom flask has a flat base. Has a flat base. But if you look at this diagram, the base is round. The question that we are looking at, the base is round. So this one is round, but this one, the base is flat. So that's why we call this one flat bottom flask. But this one, the base is round. So if you go and write flat bottom flask, you are wrong. So this one is round bottom flask. And then your II is the cork. I told you your cork is the same as the stopper. It's also the same as rubber bank. It's the same thing. And then you have So as I said, this is the same as rubber bank. Or something they say stopper. Okay. Then the II is the delivery tube. The IV that's the gas jar, but it has been turned upside down, so inverted gas jar. You can say gas cylinder. V is the basin. V is basin. If you look at VI, the VI is also pointing to the basin from the diagram. But I'm sure that the arrow should point to the beehive stand. But if you're looking at the diagram critically, your VI is also the basin. I'm sure that in the actual case, in the right question, the arrow should be pointing to the beehive stand. Okay. Now, the II says that state one function each of the parts labeled I, and IV. So you're looking at the function of I. So what's the function of the round bottom flask? So the round bottom flask is what contains the reactants. The reactants are the calcium hydroxide and the ammonia. Should be ammonium chloride, but it is written as ammonia chloride. Okay, so it contains so it is used to contain the reactant. It contains the reactant. Then the function of III, that is the delivery tube. It serves as passage through which the gas produce. Passageway through which the gas produce. Serves as a passageway through which the gas produce. Is conveyed from the flasks into the basin. So it serves as a passageway through which the gas produced is conveyed from the flask into the basin. And the last one, IV, that is the inverted gas jar, the gas jar That one is used for collecting the gas. So it is used for collecting the gas produced. Okay, so these are the functions of the part I, IV. IV, the I contains the reactant, or you can say it is the part where the reactions occur. So it serves as a place where, or a container in which reaction occurs. And then the III, that's the delivery tube, is what is used to convey or transport the gas that is produced in the flask into the basin. And then IV, that is the inverted gas jar, is used for collecting the gas produced. Question C. No, question B. It says identify 3 errors associated with the setup. So errors associated with the setup. One. Now, if you look at the diagram, one clear error is this. Your flask, the round bottom flask, is not held in position. There should be what? A retort stand and a clamp to hold the round bottom flask firmly in position. But there is no retort stand and clamp. So it means that the flask can easily fall. So that is one source of error. So absence of a retort stand and a clamp to hold bottom flask firmly in position. So absence of a retort stand and a clamp to hold the round bottom flask firmly in position. So that is one source of error. Now, if you look at the reactants, we have calcium hydroxide and ammonia chloride. I told you that in preparation of ammonia gas, you need a base. The base given there is the calcium hydroxide and an ammonium salt. So it should be ammonium chloride and not ammonia chloride. So there is no compound called ammonia chloride. So instead of ammonia chloride, it should have been ammonium chloride. So that is also an obvious source of error. So the reactant ammonia chloride should be ammonium chloride. Okay. So presence of No, instead of, let me make this sentence clear. So instead of presence, let's see. Labeling of one of the reactants as ammonia chloride instead of ammonium chloride. So that is also an error. Okay, then if you look at the PDF I gave you under preparation of gases, the setup for preparation of ammonia gas involves a drying agent, that's the calcium oxide. But in this setup, there is no drying agent. And then also, the collection of the ammonia gas, it is not over water. So ammonia gas is not collected over water because it can easily dissolve in water to form ammonium hydroxide. So collection of ammonia is not carried out over water. So that is also another source of error. So there is absence of a drying agent, that is the calcium oxide, and then the gas is wrongly collected over water. So that is the next two sources of error. Absence of a drying agent into bracket calcium oxide. And then wrongly collecting the gas. Wrongly collecting the gas using the method of collection above water. So that should be number 4. Now, if you look at this, let me also add this. You can see that in the labeling, the same thing, apparatus, has been labeled differently as V and what? VI. So that's also an error. So the basin has been labeled as V and VI. It's also an error. So labeling of basin as V and VI. Okay, so these are some of the possible sources or possible errors in the setup. You are supposed to list 3, so you can state any of the 3, any 3 from the 5. Question C. Question C says, write a balanced chemical equation for the reaction that occurred in the part labeled I. So the reaction is between the calcium hydroxide plus, so as I said, the correct reactant there should be ammonium chloride. Ammonium chloride and not ammonia chloride. So you end up getting calcium chloride plus water plus NH3. To balance, you put 2 here. If you put 2 here, you also can put 2 here. Okay, if you cross check, and they also put 2 here. So calcium is 1, calcium is 1. Oxygen here is 2, oxygen is 2. Hydrogen here is 2, there's 2 hydrogen here. The hydrogen here will be 8, 2 times 4, 8, plus the 2, making 10. Hydrogen in the water is 4, 2 times 2, 4. And the ammonia is 6, 2 times 3, 6. So 4 plus 6, 10. So the hydrogen is also balanced. And then chlorine is 2. Chlorine is 2. So that's a balanced equation. And then lastly, you have to describe a test for ammonia gas. I think in the previous session, we described, that was in question 14. We have to identify how, we describe how to identify ammonia gas, chemical and physical. So we talked about the chemical test and the physical test. So usually when you say test for a gas, you make use of the chemical test. So the gas is introduced into a test tube containing hydrogen chloride gas. The formation of white fumes shows that the gas is ammonia gas. Okay, so that is how it is for ammonia gas. I think we came across this in our previous session under question 14. So that completes question 16. So to test for ammonia gas, as you introduce the gas into a test tube containing, okay, it's introduced into a test tube containing hydrogen, so containing hydrogen chloride gas. The formation of white fumes shows that the gas is ammonia gas. Gas is ammonia gas. I told you that, I gave you even the reaction in the previous session. So when the ammonia gas combines with hydrogen chloride gas, you are going to form ammonium chloride. You form this compound. So you end up forming this compound. And that compound, the ammonium chloride, is what is responsible for the formation of the white fumes. The formation of the white fumes. Okay. So we're going to continue by looking at the next question. That is question 17. Question 17. Okay, good. So question 17. It says the figure is an illustration of a setup for the preparation of a gas in the laboratory. Study the figure carefully and use it to answer the questions that follow. So you have the setup given, and as part of the setup, you have the reactant given. So you have two reactants. You have zinc, that is in the flask, and then you have the dilute hydrochloric acid in the tester funnel. So this is a preparation of a gas which involves a reaction between a metal and an acid. When we started looking at preparation of gases, I told you that whenever you have a metal reacting with an acid, the gas that will be produced is hydrogen gas. So from the reactant, you should be able to identify the gas produced, and even that is part of the question. BI is asking you to name the gas produced. So for the fact that the reactant involve a metal and a metal and an acid, it should tell you that the gas that we produce will be hydrogen gas. Okay, so the A says you should name the part labeled I to VII. So question A. You have I. Okay, so the part labeled I. So that is a gas jar, but it has been turned upside down. So it should be inverted. Gas jar. Oh no. So the inverted gas jar is rather the II. So this is the inverted gas jar. Now your I is the gas that is collected. So as I said, the gas that is being produced is hydrogen gas. So that is hydrogen gas. That's gas collected. Okay. So anytime there is a diagram showing collection above water, if you have I told you whenever you have the inverted gas jar under the beehive stand, after the water, if you see the water, whatever is collected on top is the gas that is being prepared. So that's the gas collected. But in this case, specifically, the gas that is being produced is hydrogen gas. So that's why I've written hydrogen gas. Okay. Then your I is a basin or trough. Your hive is the beehive stand. Your V as a delivery tube. VI as a flat bottomed flask. VII as a cork. As I said, your cork rubber bank or stopper. And then your VII as a tester funnel. Okay, so these are the labeled parts. Question B, I is saying that you should name the gas produced. So the gas produced is hydrogen gas. Now the question says, II says, how could the gas produced be tested for? I told you that when you're testing for hydrogen gas, you make use of a glowing splint. So you introduce the flames of a glowing splint into a test tube containing the gas. And then when you hear a pop sound, it shows that the gas is hydrogen gas. Okay. So to test for hydrogen gas, the flames of the flames of a glowing splint is introduced into a test tube containing the gas. If a pop sound, pop sound is heard, it shows that the gas is hydrogen gas. Okay, so that is how you test for hydrogen gas. You introduce the flames of a glowing splint into a test tube containing the gas. If you hear a pop sound, and then it shows that the gas is hydrogen gas. I told you that you also use a glowing splint in testing for oxygen. For oxygen, if you introduce the flames of the glowing splint to a test tube containing the gas, the flames will rekindle. So the glowing splint will rekindle. So if the glowing splint rekindles, it shows that the gas is oxygen gas. But if you introduce the flame into a test tube containing the gas and you hear a pop sound, then it means that it is hydrogen gas. Okay. So question C. Question C says, write a balanced chemical equation for the reaction that occurred. So the reactants here, as indicated in the diagram, are hydrogen chloride, HCl, and then zinc. So you have a metal reacting with an acid. The metal reacts or combines with the chlorine, forming zinc chloride, and then the H is released as the hydrogen gas. Okay, so this is the equation. To balance this, hydrogen is formed by these two, so you put 2 here. If you do that, chlorine also becomes 2. Chlorine here is also 2. So zinc is 1, zinc is 1. So that gives the balanced equation. Then question D, it says suggest 2 methods. Suggest 2 suitable methods which could be used instead of zinc. So we can name group 2 methods, group 1 methods. So you can magnesium, calcium, iron. Can we add aluminium? Sodium and the rest. We can also add sodium. So all these are metal. Sodium, potassium, and the rest. So any 2. Okay. The last question here, question E. It says state 2 precautions that should be taken in this experiment. 2 precautions should be taken in the experiment. During the experiment, you have to make sure that in your setup, your tester funnel is immersed into the solution in the round bottom flask. You must also ensure that the delivery tube is well inserted into the beehive stand. Now, the mouth of the round or the flat bottom flask has to also be covered with cork to make sure that it is airtight. So those are some of the precautions. Okay. So 1. A tester funnel must enter into the solution and so this flat and the flat bottom flask. 2. The cork must be well fitted into the neck of the flat bottom flask to make it airtight. 3. The delivery tube must be well inserted into the beehive stand. And you can also add that the delivery tube must not enter into the solution in the bottom flask. All right, the last point here. Point 4. The delivery tube must not enter into the solution in the flat bottomed flask. Okay, so those are some of the precautions that you need to take. You can even add this there. The flat bottom flask has to be well supported and firmly held in position. Firmly held in position. Okay, so those are some of the precautions. You were supposed to give 2. I've given you 4. That concludes question 17. We're going to look at the last question under preparation of gases. That is question 18. Question 18. Okay, so we're going to look at question 18. Question 18. Okay, now this is one important question or a special case under preparation of gases. I think so far we have about 2 questions of this special case under preparation of gases. I think I've covered only one of the questions, but there's also another question. If you go to the past question, there is also another question of this sort. Why am I calling this a special case? Because in all the questions we've looked at under preparation of gases, the diagram was given. The diagram was given, and then you were asked to label the parts. But in this case, the various apparatus have been given. There's no diagram. You're supposed to identify the apparatus that have been given, and as part of the question, you are supposed to draw the setup. So in this case, the setup has not been drawn, but you have been asked to draw the setup yourself. So that is why I call this a special case under preparation of gases. Okay, so let's quickly go through it. It says that the figure below is an illustration of a setup of laboratory apparatus. Study the figure carefully and answer the questions that follow. So we have the various apparatus drawn, and then the A says you should identify each of the apparatus labeled I up to VIII. So let's look at the labeling. Question A. You have I, IV, VI, and then the last one, VIII. Okay, so the apparatus labeled I is your flat bottomed flask. Flat bottom flask. And then the II is a beaker. So beaker. The III is a Bunsen burner. Because it's a source of heat. Bunsen burner. Your IV is pipette. Pipette. Take note of the spellings. The spellings are important. Spellings are important. Okay. And then you have the V. Your V is the cork. You can say it's also the stopper. Okay. Then you have your VI, which is the gas jar. I say either it's a gas jar or gas cylinder. And your VI is a delivery tube. And your VI is a tester funnel. Take note of your spellings. Very, very key. Very key. Okay. So that is for the A, labeling of the parts. Now, from this apparatus, the B is saying that you select 5 of the apparatus that could be part of a setup for laboratory preparation of carbon dioxide from calcium carbonate and then hydrochloric acid. From calcium carbonate and then hydrochloric acid. So you are choosing 5 out of the 8 apparatus that can be used in a setup for preparation of carbon dioxide. So 1, you have your flat bottom flask. 2, you have your tester funnel. 3, you have your delivery tube. 4, you have the cork. 5, you have the gas jar or your gas cylinder. Okay. So you can see pipette. We don't make use of pipette in preparation of gases. Pipette is used in titration. Bunsen burner. In preparation of carbon dioxide, there's no source of heat needed, so you don't make use of the Bunsen burner. And then beaker. In the setup too, you don't make use of beaker. So these 3 are the ones that are not part of the setup for preparation of gases. So if you go and list any of this, you are wrong. Okay. And the question is select 5 of the apparatus. Sometimes to be even on safer side, you can decide to stick to the labeling, because probably if your name is wrong, you know the part, you can stick to this numbering. So instead of flat bottom flask, you can say I. And then the tester funnel is a VI, so you can list them in the order. Okay. And the C is asking you to draw a diagram or draw a setup to include the apparatus selected in B for the preparation of carbon dioxide. So obviously, it means that your setup, you can make use of other apparatus, but this 5 has to be included in your setup. You can simply refer to the diagram for preparation of carbon dioxide. Okay, well, let me see. Let me take my time. In drawing this, I advise that you make use of your rule in drawing so that you have a neat diagram. Don't just use your free hand and drawing. So make sure you make use of the rule and draw your diagram. Okay. Okay, so this is a diagram of the setup. So you label this as your, so say hydrochloric acid, and then this is your calcium carbonate. So calcium carbonate. And then what is in here is the hydrochloric acid. Okay. You have most of this, the part already indicated here. You have your cork, you have your delivery tube, the gas shaft. So the ones that you have introduced here is the rector stand, the tripod stand, the basin, and then your beehive stand. Okay. So the gas here is the hydrogen gas. This is the basin. What is it? This is the water. And then this one is we have stand. I'm only labeling the parts that were not here. And this is the tripod stand. And then you have the rector stand. Okay, so the other parts have been indicated in A. So that's for preparation of carbon dioxide. As I said, here there shouldn't be any source of heat. That's why the basin burner is not there. In your diagram, you should always ensure that the tester funnel is inside the solution in the flask. Your delivery tube must not be inside the solution, it has to be outside. And the delivery tube should also be well inserted into the beehive stand. And then also the neck of the flask has to be well fitted with a cork to make it airtight. Okay, so those things you have to make sure you take note of them. And then the last question says, describe the test for carbon dioxide. We've come across this already, how to test for carbon dioxide. So you make use of lime water. So you pass the gas through lime water. And when the lime water turns smoky, it shows that the gas is carbon dioxide gas. So to test for carbon dioxide, the gas is bubbled. So the gas is bubbled through a test tube containing lime water. When the lime water turns smoky, it shows that the gas is carbon dioxide gas. Okay, so The gas is carbon dioxide. The gas. So the gas is carbon dioxide gas. Yesterday I gave you the equation for this test. Told you that the lime water is calcium hydroxide. Calcium hydroxide. And then, so if you react the carbon dioxide with the calcium hydroxide, you are going to form calcium carbonate and water. The calcium carbonate formed is actually a white precipitate. So that is what is responsible for the cloudiness or the murkiness. So it can be asked that in test for carbon dioxide, what is responsible for the murkiness or responsible for the cloudiness? It is because when the carbon dioxide is bubbled through or passed through the lime water with its calcium hydroxide, calcium carbonate is produced, and that is what is responsible for the murkiness. Please take note of this question. For me, I believe that if you're going to get a question under chemistry practical involving preparation of gases, it is likely that you will be given a question where you'll be asked to draw the diagram. So take note of this. As I said earlier on, preparation of gases is one important aspect of chemistry practicals. So make sure you take note of all that we've done under preparation of gases. On that note, this brings down the curtain on preparation of gases. We are left with the last aspect of chemistry practicals. As I said before, or I said at the beginning of today's session, the last aspect of chemistry practice involves titration. So in our next session, which is the last session for chemistry practicals, we're going to look at question 19, question 20, and question 21. All those questions falls under titration. Okay, so please, as I've always been saying, stay home, stay safe, and make sure you judiciously spend quality time and study assiduously in preparation of your examination. Until you meet again, God richly bless you.